So recall the fundamental theorem of calculus is the connecting link between the definite integral, which is computed on this side here, and the antiderivatives, which are, so f is an antiderivative. So this f, capital F, is an antiderivative of this small f function. So that means this is a connection. Okay. So now let's see how this is going to help us basically compute the definite integral of the function. Okay. So we have already established this connection in the last class. So here, so let's define what is the definite integral. It's another labeling for antiderivatives. So the symbol integral of f of x dx is called indefinite integral, and it represents the antiderivative of f. What does it mean? It means that integral of f of x is dx is this capital F of x if f prime x equals to f of x. This is a connection. Okay. Now, note that this notation, integral f of x dx, is used to represent set of all antiderivatives, not just one, but all of them. So integral f of x dx is collection of all those function f whose derivative when you take, you get small f. Or in other words, it's collection of all the antiderivatives of small f function. And one of these single function is called antiderivative, but collection of all these antiderivatives gives you the integral. Okay, so that's the connection. So these are the few integrals you should already know, that c f of x dx, the constant comes out of the integral. Again, these follows from the laws of antiderivatives, c times f of x. If you have f of x plus g of x, it becomes integral f of x dx plus integral g of x. Right? So in this case, if the function is 1, so you have k dx is going to be integral, k comes out, integral of dx plus dx, and that is going to be kx plus some constant c. Similarly, you can see that if since derivative of this guy is equal to x to the n, therefore antiderivative or integral of x to the n is x to the n divided by n plus 1, and plus a constant c, where c is the constant of integration. Okay. So this can be seen directly. So how do you build the connection? Take this guy and take the derivative of this and see if it matches with x to the n. So you can see that here. So derivative of x to the n plus 1 upon n plus 1. And this is the case when n is not minus 1. You will see that this is going to be 1 upon n plus 1 is a constant, so it comes out. Derivative of x to the power n plus 1 is n plus 1 times x to the power n plus 1 minus 1. This, guys, will cancel because n is not minus 1, so n plus 1 is not 0, so you can cancel them out. You get this is equal to x to the n. So this implies integral of x to the n dx is x to the n plus 1 divided by x to the n plus 1 plus a constant c. Okay. Similarly, you can see that derivative of ln of absolute value of x is 1 over x. So therefore, antiderivative of x to the power minus 1 dx is ln of absolute value of x plus c. Similarly, derivative of e to the x plus c is e to the x. So therefore, integral of e to the x dx is e to the x plus c. Same way here as well. Derivative of a to the x is a to the x ln a. Divide both sides by ln a. This would give me 1 by ln a d by dx of a to the x is a to the x. Bring this constant inside. ln a is well-defined constant. Why is that? Because recall, when we discuss exponential function, we always discuss it for a greater than 0 and a not equal to 1. So for which the ln a is non-zero number. So we get, this implies d by dx of a to the x over ln a is equal to a to the x. So therefore, is going to be a to the x over ln a plus c. Similarly, derivative of sine x is cos x. So therefore, an integral of cos x is sine x plus c. Derivative of tan x is secant square x. So integral of secant square x is tan x plus c. Derivative of secant x is secant x tan x. So therefore, integral of secant x tan x dx is secant. Okay, so on and so forth. Right. So these are the opposite of. So the integral is opposite of uh, derivative, and we have already seen these things before. So let's try to find out the following indefinite integrals. So again, first one, we have x to the power minus 2 by 3 dx. In this case, we'll use the power rule, which is going to be x to the power minus 2 by 3 plus 1 divided by minus 2 by 3 plus 1 plus c. And if you simplify this, this is going to be x to the power 1 by 3 divided by 1 by 3 plus c. And that can be written as 3 times x to the power 1 by 3 plus c. Now let's look at b. In b, we can multiply it out. So we get 3t square minus 4t to the power 7 dt. Now using the sum rule, you can break the integrals and you can take the constants out. So we get 3t squared dt minus 4 times integral of t to the power 7 dt. Now again use the power rule. So we get 3t cubed to t to the power 2 plus 1, which is 3, divided by 3, 4 times t to the power 7 plus 1, which is 8, divided by 8 plus c. And if you want to rearrange this slightly, this will be t cubed minus t to the power 8 divided by 2 plus c. Now let's look at next problem, c. So in this case, we have to multiply it out first and then take the integral. Yeah? Because there's no product rule, at least for now, for the integrals, right? So this is going to be, so if you multiply it out, so this guy multiplies with both of them, so you get u cubed minus u square, then you multiply with 3, so plus 3u minus 3 du. And then when you integrate, you get u to the power 4 over 4, again using power rule, u to the power 3 divided by 3 plus 3u squared divided by 2 minus 3u, and then plus c. Okay. So this is how this game is played. How about d? For d, you should notice that this is 4e to the power v minus secant square v dv. Now we'll break it, we'll split it, so we can take, using the sum rule and take the constants out, we get e to the power v dv minus secant square v dv. So integral of e to the v with respect to v is e to the v. Integral of secant square is tan, because derivative of tan is secant square, plus constant c. Now let's look at the next one, which is e integral of cos z upon 1 minus cos square z dz. So this one. So in this case, we'll try to simplify it to make it look like something we already know. So if you convert the denominator into, so cos square z is same, 1 minus cos square z is same as sine square z. So we have cos z upon sine square z dz. This is going to be cos z over sine z times 1 by sine z dz. This is going to be cot z or cotangent z times cosecant z dz. And that is going to be what? That is going to be so integral of this is going to be minus cosecant z plus c. So this is how the game of integrals are played. Okay, so let's move on further. So if you're given, so fundamental theorem of calculus gives us that if you integrate f prime x dx, it's going to be f of b minus f of a. Now note that f prime represents the rate of change, right? Derivative after all represents the rate of change with respect to, in this case, with respect to x. So now integral a to b f prime x dx is going to be f of b minus f of a. This is according to the fundamental theorem of calculus 2. So what does this mean? This means that if you look at this theorem, if you integrate rate of change, you get a net change, right? What is the net change? How much did your function change from A to B, right? So this represents the net change. So let's ask the following question. If f of x is the slope of the hiking trail at a distance x mile from the start of the trail, what does integral 2 to 4 f of x dx represents? So the question is, what will integral 2 to 4 f of x dx represent? You have basically, this is your distance, and you have, this is your function f of x. Then f prime x, what does integral of, this is your f of x, this is 2, so this is 4. Now f prime x will represent the derivative of this function. So question is, what does integral of f of x dx from 2 to 4 represent? This represents basically change in elevation. Rather, we should say net change in elevation from what point x to x equals to 2 to x equals to 4. Okay. Now let's do the following problem. So a particle is moving along a straight line with an acceleration at is 2t plus 3. Initial velocity is v0, which is minus 4 meter per second, and t is between 0 and 3. The question is, what is the velocity at time t? So note the following. So if you take acceleration, or rather if you start with position, if you differentiate, you get velocity. And if you further differentiate, you get what? Acceleration. And how do you go back? Instead of differentiating, you should take what? The integral. And then from here to here, you have integral. Okay. So now you are given, you have a of t equals to 2t plus 3. You're given v of 0 is minus 4 meter per second, and your t belongs to 0 to 3. So this is the information given to you in short. So now what is the velocity? Velocity is given by v of t, which is integral of a of t dt. This is going to be integral of 2t plus 3 dt. What is integral of 2t? Is t square. Integral of this is 3t plus a constant c. Okay, you should always make sure to add this constant. All right, make sure to add constant of integration. So what do we get? So we got this is your velocity. Now, of course, if somebody says I have 20 plus $C in my account, and that is not a complete description of your answer, right? That C could be 1 million, or C could be minus 20, or C could be minus 1 million, right? So we need to find out what is the C to get a complete description of your velocity. So for that, notice that we are given some more information, namely V of 0 is minus 4. Yeah, given. But if you put it in the formula, you get what? 0 square plus 3 times 0 plus C. Yeah, from formula. So this will give me C equals to what? C equals to minus 4. And in that case, V of t is going to be t square plus 3t minus 4. Right? So you can check that if you take derivative of this velocity, you will get acceleration back. So this is the first part. Now, second part is asking you the distance traveled during this time interval. So what shall I do for? So if you integrate velocity from 0 to 3, this will give you the displacement. Yeah. So this will give you displacement. Say, for example, I traveled from 1 to, say, 3. So 1 to 2, I say went from, say, from here to FIC. Let this distance be A1. So this is amount of, so this is my time, this be my velocity. So the integral is the area under the curve, which will be the displacement. So this will be the displacement going to SFU or going to FIC, say. Now, on the other hand, then when I go from FIC back to home, from college, if I go back to home, this will be A2. And then if you integrate from 1 to 2, say this is 3. If I integrate from 1 to 3 of V of t, this will give me what? This will give me 0 because I'm back. So this is where I was at home. This is where I'll be back home. Yeah, so the net displacement is 0 if A1 is equal to A2. Whereas the distance traveled is not 0, right? So the distance traveled is area below this curve and again this curve. So basically distance traveled, so the distance traveled is integral of 0 to 3 of absolute value of v dt, right? So we get this is equal to, now note that when you have to integrate the absolute value, so you want to get rid of this absolute value sign, right? So how do we get rid of this absolute value sign? So recall absolute value of x is equal to x if x is greater than equal to 0. and minus x if x is less than 0. So we need to determine when is the velocity. So let's see. So we have 0 to 3, absolute value of t square plus 3t minus 4 dt. And we want to get rid of this absolute value sign. So first determine where it becomes 0. So t square plus 3t minus 4 equals to 0 implies t plus 4 times t minus 1 equals to 0, which means either t equals to 1 or t equals to minus 4. Out of that, this is not in our consideration since this does not belongs to 1 to 3, sorry, 0 to 3, right? We are interested in 0 to 3. Now you have to see if t, what is the sign of this guy, right? So now you have at 1, things are changing. So you have 0, you have 3. So we are interested in sign of t square plus 3t minus 4. Take a point of your choice. Say, let's take 0.5 here. So if you take 0.5, then you substitute here. So you'll have t 0.5 plus 4, which is 4.5, 0.5 minus 1, which is negative. So negative, positive times negative is negative here. Similarly, let's take 2. So when you have here, it's positive, here it's positive. So here it's going to be positive. So this distance traveled, let's call this d. So this d is going to be 0 to 1, absolute value of t square plus 3t minus 4 dt plus 1 to 3 t square plus 3t minus 4 dt. Now we need to get rid of the absolute value sign. So here you see between 0 and 1, this function has a negative sign. So when you want to get rid of the absolute value, you will put a 1 minus sign in front of it, because absolute value of a negative object or negative number is minus of that. And in 1, 2, 3, this function is positive. So we will write it as it is. So 2 plus 3t minus 4. Now let's expand it out and integrate. So we get t cubed by 3 plus 3t square by 2 minus 4t. The minus sign, I'll keep it out, 0 to 1, plus again t cubed by 3 plus 3t square by 2 minus 4t, integral from 1 to 3. Now in this case, you just have to substitute the upper limit because the lower limit will give you 0. So minus of 1 by 3 plus 3 by 2 minus 4 plus, now in this case, we have to substitute upper limit minus lower limit. So when you put upper limit, you get 27 by 3 plus 3 times 3 square, which is 27 by 2 minus 4 times 3, which is 12, minus of, again, this thing with the minus sign, we have 1 by 3 plus 3 by 2 minus 4. Now we need to simplify this. So let's see, what do we get? Here we get minus 1 by 3 plus 3 by 2 minus 4. So let's see. So that is going to be minus 11 by, so we have 2 plus 9 by 6. So 11 by 6 minus 4 plus 9 plus 27 by 6 minus 12 minus, again, this is going to be minus 11 by 6 minus 4. So what is 11 by 6? So 11 by 6 minus 4 is 11 minus So this is going to be 11 minus 24. So 11 minus 24 is 13 with a minus sign by 6 times 2, because you have the same thing here. Minus minus makes it 2 times, plus 27 by 6. So 27 by, this was 27 by 2. So 27 by 2 minus 20. So we get 27 minus 24. So 27 minus 24 gives you 4. So the answer is 89 over 6. All right. So this is how you go about the problem. Okay. So again, when you're integrating an absolute value, you have to see where it is positive and where it's negative, and then go from there.